want to start our time together by asking y'all a question. Can you raise your hand for me if there's like some amount of legacy code in the systems that you work in regularly? Yeah, okay. Almost every hand is up. For you folks whose hands is not up, has your company existed for more than like 3 days? I'm just curious. If you don't have legacy code today, don't worry, you will. And it's really easy to hate on legacy code, right? Like you're scrolling through some old piece of the code base and you're like, who decided to use this framework that came over on the Mayflower or this design pattern from, the late Jurassic? And who thought this was a good idea? The cool part about that is sometimes the answer, in the Taylor Swift of it all, is it's me. Like, I'm the problem, right? I'm the one who made these fascinating decisions. I can't be the only one who's been like scrolling through GitHub and been like, well, that was a weird choice. Git blame just for my own name to pop up. And you're like, oh, well, the Shawna of 2 years ago was making decisions. But what I want to argue today is that if we build code that lives long enough to become legacy code, we've done like a pretty good job. Legacy code often just works, and it's often worked for a long time. And it's legacy code because we didn't have to touch it, right? And I have dealt with a fair share of legacy code in my career. Like Michelle just mentioned, I'm currently at Carta, where I'm a senior staff engineer. But before that, I was director of software engineering for Verizon/Yahoo. Acquisitions are weird. They're a big data platform. So think about a company like Verizon. They have functionally existed since the invention of the telephone, which was like not 2 weeks ago. They had a lot of legacy code laying around. And Carta's not nearly as old as that, but we have our own fair share too. And when I say legacy code, I don't blame you if you immediately think tech debt. But I want to argue today that legacy code and tech debt are not synonyms. That these are orthogonal concepts that we can consider along two axes. At one axis, we have technical debt, and on the other end of that is something like ideal architecture or something. Then at the bottom, we have that legacy code, the stuff that has been running without needing a lot of attention for a while. And on the other end, we have our active code. It's not necessarily like new, but it's something that's getting our attention a little bit more regularly. And when we think about these different quadrants, like the really nice code that's a joy to work with and like well-tested and like has a slight sheen on it when you look at it, that's the gold standard code. That's the stuff that's like really nice to use. It's hard to use wrong. At the other side on the top, we have that code, maybe we just shipped it yesterday, but it's got some tech debt associated with it. And there could be lots of reasons for that, right? Like maybe this was a feature that was rushed, or it could be that you sat down and you looked at the trade-offs that you had to make and you said, I'm going to accept some tech debt right now so that I can perform this experiment. This code isn't necessarily bad. It's a little bit harder to work with. There's more friction. I call that our tangled code. But not all legacy code is tech debt. We probably have that code that's been running in production for a long time. It's delivering value, works pretty well, but maybe it's using an old framework or convention. I call that our vintage code. And in my experience, a lot of there's a fair bit of vintage code that's like running our businesses probably as we sit here literally right now. Okay, we're coming to the really fun quadrant, right? The thing that is not just full of tech debt, but is like older than the hills. I call that our deadweight code. And everything we're writing right now and everything we have today falls in these axes somewhere. And just with the sheer passage of time, the code that's in those top two quadrants, it's gonna fall down, right? So what I want to talk through today is, this is funny, I was talking to a friend of mine about this talk, and he's like, this is like a This American Life episode, because you have a story in 3 acts. So, and I'm from Chicago, so WBZ makes sense. Thank you, yes, right, exactly. There is not a better NPR station, I will fight you later. So we're going to have this story in 3 acts. We're going to start by talking about like, okay, we have code, maybe we have code in those bottom 2 quadrants. What work do we need to do to like try to lift it up closer to the top? And then if we're thinking about code in those leftmost quadrants, what do we do to like shift it closer to the right? And while we're doing all this code shifting, we're like inevitably building something new. How do we build that new thing with the future in mind. How do we build it so that it's like eventually, someday, easier to deprecate? In most cases, it's the legacy code that got our companies and our businesses and our products where they are today. But often the code that got us here won't get us there. And that means we're gonna have to replace that legacy code. We're gonna have to build something new. And that thing that we're building now, maybe the code you're building like literally today, that is ideally, if things go like really well, that is the legacy code of tomorrow. And someday, that legacy code is going to have to be replaced, right? Like this is a cycle, nothing lives forever. How do we build the code today with that inevitable end in mind? How do we build it thinking about how we will someday need to deprecate it? If we keep those ideas in mind, I feel really strongly that we will build better, more maintainable code that will make us cry way less when we finally have to delete it. So this is pretty abstract in general. And what I want to do to ground our conversation today is actually walk you through an example of doing this work in the wild. This is a project we had at Carta where we had the joys of tech debt, legacy code, and needing to build something new. And in order for that to make any sense, I need to tell you a tiny bit about our business so that anything I'm going to say is reasonable. The project had to do with how Carta integrates with a third-party HR provider, think like a Workday or a Rippling. So briefly, why is this a thing my company gives a hoot about? Fair question. One of our business lines is cap table management. So if you're managing somebody's capitalization table, it's really important to understand when that company hires new people or terminates folks, because those changes impact the customer's cap table. And we call this stakeholder management, like on our platform. In order to provide some automation around that stakeholder management, we will integrate with your HR provider, because you have to tell them anyway, right? I hired this new person. Rather than making you go tell your HR provider and then tell Carta, just let automation propagate that information through to the Carta platform. And this is something we'd done for a long time. It had been running in our monolith for years. But like I said, sometimes the code that got us here won't get us there. We reached that point with our HR integration support a few years ago. Our existing implementation had grown pretty organically over a fair number of years. And that led to some limitations. We weren't exposing a consistent data contract across our providers, and that was a problem because we were looking to introduce a new business line, specifically a business line that was going to deal with helping our customers understand how to do compensation. Yeah, compensation is really interested in your HR data, right? So this was an important thing for us to support, but we couldn't. And to make it even stickier, the code was old enough that there just wasn't that many people around anymore that knew how any of it worked. And those of us who were tasked with solving this problem had never seen the code before in our lives. So what could possibly go wrong? To start with, this is where we began. And this picture actually looks relatively reasonable, I think. But as we looked to introduce this new compensation product, we ended up in this situation where, depending on who your HR provider was, that dictated whether or not the data was available in the compensation product. How in the world could that be? That sounds wild. Well, I've got this nice box situation around the HR integrations, and you're like, surely that was some sort of unified module that had some sort of consistent data contract. Haha. Not exactly. I think this is a much more fair picture of how this worked. We basically had a bunch of disparate provider implementations that had almost nothing to do with each other. And then we're tasked with okay, go fix this. This thing that's powering an incredibly business critical product in that stakeholder management box that our customers use literally every day. And if you break it, they will come for you. And none of us knew how this code worked. So we really weren't that interested in just mucking around in here and finding out what we might break. There were real consequences. So this is the real life scenario that we were in. You're having a conversation with the customer who's like, oh, I'm super jazzed about your new compensation product. That sounds awesome. You need my HR data, right? And then you're like, we do. And the cool thing is we support your HR provider, just not like that. It's a bananas thing to say out loud. This was real life. we were very firmly in that dead weight quadrant. Like we had tech debt, we had legacy code, but what we wanted to do, we wanted to find a path to gold standard, right? Don't we all? Like ideally, we will all build code that lives in this quadrant. This is a really big shift. It doesn't really get, you can't do a desirable shift much bigger than this. We wanted to go from the bottom left to the top right. Where do we start? So let's look at this in a few different ways. I said we were going to have a story in 3 acts. Our first act is, if we have code in these bottom 2 quadrants, what do we do to try to lift it out of there? And we have a few different options, right? We can rewrite our code in place. We can do the thing where we stand up some new system, and then one morning we like shift over all of the traffic and pray. Just saying that out loud gives me anxiety, but sure, you could do that. Or you could use something like the Strangler Fig pattern to gradually replace your legacy system over time. And if you aren't familiar with Strangler Fig, don't worry. We're going to dig into the specifics of that in just a second. But what do you choose, right? A rewrite in place makes a lot of sense especially for a relatively small problem. Like it's nice that you can work alongside the code that exists today and really appreciate like how is it reasoning about certain edge cases, and like you're right in there in the weeds. But it can be hard when you're doing a rewrite in place if your system is complex and like the rewrite you need to do is large. If you need to change functionality, do you end up with like a bunch of feature flags all over the place that are trying to decide which world you live in? You don't want to be the person that like puts up the 10,000 file PR and is like, I'm done, everybody. Like that's probably not how you want to do a giant rewrite like this. So for reasonably localized changes, a rewrite can work, but we had such a significant change, we just didn't see how this was going to be the path forward for us. Yeah, I've already tipped my hand that maybe this one's not my favorite. Like you can stand up a brand new system and in one giant switchover just like move all the traffic. Like that is technically a thing you can do. And I have seen it done in the past. I've just never seen it go particularly well for a thing of any real complexity. And this is probably when I should say I am wildly risk averse, so this just like goes against who I am as a person. To be very fair to this pattern, you can do this, especially if you have like a relatively small blast radius. Like this is a reasonable path forward. I probably still would never do it because it gives me so much anxiety, but that's probably more of a me problem than it is with this particular approach. And I probably sufficiently demonstrated that this one's my favorite, probably. I really love the gradual replacement approach, something like Strangler Fig. And I have actually given entire talks about why I think Strangler Fig is the best thing since sliced bread, which is not what I'm going to do to you right now, but I am going to force you to listen to just a little bit about it because I think it is the most effective way for us to actually like get out of these bottom 2 quadrants. So if you're not familiar with the Strangler Fig pattern, it's named after a real plant called the Strangler Fig. And how those plants work is they start at the tops of trees and they slowly grow down to the soil, eventually actually killing the host tree underneath it. They're a parasite. So the Strangler Fig replaces the legacy tree. It's not code, but you have a replacement in the Strangler Fig. The pattern is basically trying to do exactly the same thing. The idea is that you have your legacy system and you slowly migrate functionality into your new system until one day you have all your functionality in your new system. So how does that actually like play out in practice? When you're using the Strangler Fig pattern, it says the first thing you need to do is build a facade. The pattern calls it a facade. I often call it just a proxy. It's a very simple piece of software. Hopefully it's a very simple piece of software. It says for a given piece of incoming traffic, should this traffic go to the legacy system or the new system? And when you start out, it will be the least interesting piece of software in the world because all of your traffic will go to your legacy system. Your new system doesn't do anything yet. So next you have to go into your legacy system and find these like individual modules that you can independently migrate into your new system. This is the part of this entire process that I think is much more of an art than a science. And if you don't have good modules in your legacy system, you may have to like go introduce them, which is its own, that could be its own like talk on its own. But this part is really important because you really can't proceed until you have these individual modules. So then you're going to move functionality from your legacy system into your new system, basically one module at a time. So we have this like this blue hash mark situation in the legacy system, we haven't actually changed any of the behavior of module 1 and module 2 in the legacy system. We've just replicated that functionality in our new system. And now we go to our facade and we say, okay, facade, if you see traffic that requires module 1, send that to the new system because that is supported in the new system. But if you see traffic that requires module N, send that to the legacy system because it doesn't support that yet. And then you gradually, over time, introduce additional modules into your new system until one day, everything's migrated, and you remove your facade, and you delete your legacy system, and you probably have a party because you've finished a migration, and that's like a big deal. The thing I love about this pattern is that it gives us like so many fallbacks and safety nets. There's a lot of psychological safety in the leveraging of Strangler Fig. But there are drawbacks. Everything's a trade-off, right? Like nothing's perfect. You can end up with a foot in both worlds for a really long time. That can be frustrating. You also have to do the work of understanding, how do I tell my facade how to route stuff? How do I have visibility into what the facade is doing? Like these things are additional work. But in my experience, the benefits have consistently outweighed the drawbacks in any upgrade of any real complexity. And Strangler Fig actually lets you do this like in real life, where you can find yourself moving from dead weight eventually to something that is much closer to the gold standard. And it's in fact the only way I've ever felt like I've accomplished this in my life, I think, yeah. But the other cool thing about Strangler Fig is that it's not just a pattern for when you're actively deprecating your legacy code. It's also a pattern that you can use to consider how you build your new system. Like, how can I, as I am designing this new system that I'm building, imagine the future developer, could be me, who has to replace this new system in some modular way? How do I make that job easier for that future person? So how did that work for our specific example? The unique thing about when we started designing our new HR system based on this existing behavior was that we actually talked about at the beginning, before we'd written a single line of code, in this new system, how are we going to ensure that Strangler Fig will be an effective way to someday deprecate it? And I think that that fundamentally changed how we reasoned about our new system. We knew that we wanted to get to a place where at the very least, it didn't depend on which provider you were using. You could like use all the downstream products. That seemed like a bare minimum. But we also wanted to understand that this was gonna be true going forward. Like if we needed to introduce a new provider, we weren't gonna have to do a bunch of work to ensure that the data would seamlessly flow downstream. We also knew we wanted to decompose from our monolith so that we could just move faster than how we were iterating in the monolith back then. So we designed this, which is like way different, right? Like this, there are some of the same colors as the other one. Other than that, this is very different. There's an entirely new service that didn't exist in the previous picture. There's a message bus. Where did that come from? Like this was a really big change. And that meant, well, we were gonna have to do a bunch of work. All right, this had both directions that we needed to move. So the first part we talked about, like, how are we going to move from the bottom to the top? But now, how are we gonna move from the left to the right? This is a slightly different shape of problem. Often when we're replacing legacy code, we are like building some often significant new something to replace it. With TechNet though, that comes in a lot of different shapes and sizes, right? And you often know like what you wanna do to fix it, but the hard part can be getting anybody on the planet to add it to a roadmap before like 2080, right? Like you need to have some time to do it before the heat death of the universe. So how do you go about reasoning about actually getting buy-in to do this work? There are lots of questions that we have to ask ourselves when we are starting this consideration. And the first one is, should I pay down this tech debt at all? The cool thing about the answer to that is it's the answer to everything in software engineering. It depends. But also this section on tech debt, I think is like 62% hot takes. So please, you have been warned. You shouldn't pay down tech debt unless you have a business need. I learned like 3 days ago that this is the controversial opinion puffin, I think. I was very much in love with that because this is probably one of the more controversial takes I have had in my career. And I get it. Like, we're engineers. We like to build things. We like to rebuild things. We especially like to build things that are super shiny. Like, it makes sense that we want to pay down our tech debt. But paying down tech debt just isn't a goal of its own. And when we're thinking about like, what questions can I ask myself? Think about like, what's the opportunity cost of doing this right now? What's the cost of waiting a month to do this work? And if we can't justify those costs, probably now is the wrong time. And I'm sure that most of us have had those really hard conversations with like a product manager or an engineering manager where you're like, listen, 3 weeks ago, I put in this hack that is keeping me up at night. I just need time to go back and fix it. And they're like, but it's working. I don't understand the problem. Or this library is like driving me up the wall. Those are often not super persuasive arguments. But if you can find this intersection of some business need and your tech debt, now we're talking about a place where like PMs and EMs, they're interested, like tell me more, right? And there are so many ways that you can link tech debt pay down. Like this could be a slide with 700 things on it. It's not, but it could be. There are so many ways that we can link a tech debt pay down to a business goal. Like maybe you're figured out that if I pay down this tech debt, it's going to make it way easier for me to onboard new team members. Or I'm going to speed up our CI pipeline by 3x. Or I'm going to be able to squash this bug that has been recurring for customers over the last 6 months and that people are really angry about. All of these are pretty clearly linked to a business goal. And if you can find this link between your task and the business goal, you're much more likely to get buy-in. And if you can't, that probably means that now is not the right time to do this work. Every system I've ever worked in had some amount of tech debt, unless it was literally empty. And that tech debt isn't necessarily bad in all cases. Like we take out debt to buy our cars or our apartments, right? Like that's not bad debt. There are also forms of tech debt that are just fine. So how did this look in our HR integrations example? What was the tech debt that we needed to pay down here? It was pretty clearly this wildly disparate data exposure layer. Linking this to a business goal was really easy. We actively wanted to release a product that we could not reliably support. I didn't have to convince anyone that releasing the product was a valuable thing to do. But if I had tried to convince people, even say 6 months earlier, that this was work that we should do, I don't think I would have gotten any buy-in because it was super weird that this was how it worked. But it didn't matter. It wasn't stopping us from doing anything that we wanted to do. It wasn't until we had an active business need that it became very clear that this was the right thing to do. Okay, we've talked some about how do we deal with our stuff at the bottom. We've talked some about the tech debt stuff on the left. That brings us to our last part. All right, well, we've got to build something new, right? How do we build that code so that it ages really well? They say Paul Rudd doesn't age. He clearly does, just remarkably slowly. How do we build the Paul Rudd of, he definitely lives in the gold standard. How do we build the Paul Rudd of our code, right? How do we keep our code in this gold standard quadrant just as long as we can? We want to build code that ages well. And in my experience, the code that ages the best is the code that's the hardest to use wrong. And there are a zillion ways that we can make our code harder to use wrong. I picked 4 of them. I looked back on our experience working on this new HR integration system, and I talked to a couple of folks who had worked on it with me, and I was like, what were the things that really stand out to you that made a big difference when we were doing this project? And these were the 4 things that bubbled up. So I want to go through these one at a time. How do we think about these things as tools? I'm not going to read it to you. How do we think about these things as tools to build code that ages well? Okay. I mentioned that we use Strangler Fig. while we were doing this work. And one of the key parts of Strangler Fig is that encapsulation element, right? That those individual modules that help us as we're trying to do these incremental migrations. And if there's just one thing that you leave here with, I would hope that encapsulation is the single best tool I have ever encountered to help build code that ages better. Now, what do I mean by encapsulation? Just basically hiding the gnarly internals that almost certainly exist within our components and exposing clear interfaces that are the way that your components can communicate with each other. And when we encapsulate our code, we create a software seam. And this idea of software seams comes from Michael Feather's book, Working Effectively with Legacy Code. A seam is a place that we can alter the behavior of our software without actually having to touch the code in that place. And when we're leveraging Strangler Fig and you're looking for those independent modules, those are your seams. And for us in the legacy system, we're actually pretty fortunate. The seams were really pretty well defined. They were these individual HR providers. We could seamlessly, I'm sorry, I couldn't help myself. We could seamlessly move those between the legacy implementation and our new implementation because they had good seams around them. But sometimes you're not going to be that fortunate, and you're going to find yourself that the first thing you have to do is actually introduce the seams in your legacy system. And this on its own could be like a 6-day seminar, which we're definitely not going to do. But just from a very high level, look for ways to isolate the components in your legacy system. Can you add new layers of abstraction? Can you add wrappers around different parts of the code to just hide those internals? That's going to be a really important part of ensuring that you can deprecate that legacy code. Again, just like when we were talking about Strangler Fig, this is more of an art than it is a science. But if you find yourself actively having to do this work, I would encourage you to go get your hands on Michael Feather's book because it is an outstanding resource when you're in the weeds and actually having to do this. And so for our HR integrations project, as we were building out our new code, we were actively discussing, well, what are the seams that we need as we're going forward? Because we wanted to ensure that this new system was well encapsulated. And they manifested in a few different ways. First was just ensuring that we were maintaining the existing seams within these individual HR providers. So, if we needed to change the behavior of one of these, that should be completely transparent to absolutely everything else in our system. If something about namely changes, that only component that needs to know about that is the namely component. So keep each provider encapsulated. This was more about ensuring that we maintained the existing levels of encapsulation rather than introducing new ones. But we did have to introduce new ones as we were designing our new system. And I want to tell you about that, but I have to give you like a teeny bit more detail on how this system worked, or nothing I say about that will make any sense. So Carta synchronizes this data from the HR providers on a schedule. This is just a very boring set of crons, right? We're going to run Dunder Mifflin at 3 o'clock, and then we're going to run Stark Industries at 4 o'clock, and tomorrow we're going to do it all again. And historically, there had been this really tight coupling between the provider and the scheduling. But we really did not want to maintain this tight coupling going forward. We did not want to have to go into each individual provider if we wanted to change something about how we were scheduling this. What we wanted was to create a seam around the scheduler, even though we knew the only scheduler we were going to start with is a cron. And if you're asking yourself, well, why would you do the work to encapsulate if you didn't have another use case? Because the encapsulation on its own was super useful. And we knew that we were expecting to have a use case for a webhook sometime in the future. This makes sense, right? Rather than us having to go poll the third-party system to ask for changes, it knows that there are changes. Just come and tell us. This was something we knew we would eventually want to support. But what we built for that to begin with was nothing. We didn't build any of the webhook implementation to start with. And that wasn't an accident. We didn't have a use case, so we didn't want to build out that code. So, what's my point? We didn't build that webhook implementation because code that doesn't exist can never break. If we had built it when we didn't need it, I mean, I know myself. I definitely would have had some wild bug that on like alternating Thursdays when we tried to schedule the cron, it hit something in the webhook implementation because I made a bad decision, and then the whole thing went to heck, right? Like my life is repeatable enough that it definitely wouldn't have gone well. And also, when we write that code that we're not using, do you know what code ages the absolute worst? Code that isn't being used, because there's absolutely nothing to encourage you to keep it up to date. So when your code is well encapsulated and only exists when you need it and has these well-defined seams, you're going to have a more reliable system. A lot of the ways of like building out these new systems is just finding ways to make our code easier to use right, harder to use wrong. Seams are a great way to accomplish that. And good seams are also really important to the next part of this that I want to touch on, and that is testing. So talk about another thing that could be a 6-day seminar, the joys of testing and why they are great and how to write them. We could go on and on. But what I want to talk about specifically around testing here is how do tests help our code age better? Like, how do we write these so that as our code ages, it's more reliable and easier to use? Now, we can all write bad tests. I am implicitly talking about good tests. Bad tests at best inflate some coverage number that doesn't particularly matter, or at worst create so much noise that we just like abandon testing altogether and throw our laptops into the sea. Like what we want to write here is good tests. And writing tests helps us maintain reliability as our code gets older, because like time is coming for all of us. It's coming for us and it's coming for our code, right? It's going to fall down just with the passage of time. But tests help us stave off this inevitable fall, at least for a little while. Because as our code base evolves and as it ages, those tests give us the confidence to actually make changes. And we can rest soundly at night knowing we didn't break any existing functionality as we end up having to work in some part of our code base. It also means that we're going to be able to adapt more quickly because our businesses are inevitably going to change. And if we have a reliable test suite around that code, we're going to be able to respond to those business needs more quickly. And when we combine our seams with our tests, that again is going to create more maintainable code that's going to age better. I think you are required by law to have the testing pyramid in a deck if you're talking about testing, so I did, that's fine. One of the things I wanted to touch on was like, how did we think about testing as we were taking on this HR integrations work? Because the deadweight code, I would say, generously had spotty test coverage in the legacy system. We didn't really have a lot of confidence that we weren't going to break something. So the first thing we did was introduce a bunch of end-to-end tests in the legacy system so that as we iterated and were working through Strangler Fig, we could at least feel fairly confident we weren't breaking anybody's like mission critical workflows. But we also, of course, built out the tests for our new system, end-to-end, the sorts of things that you would expect. And because we had these really clear seams, the tests in our new system were actually pretty easy to write. Like we could inject mocks where we needed them. Our components were relatively well isolated, so you didn't get a lot of that stuff where like test A is slamming over test B on every second Wednesday and your tests flake out for no good reason. We didn't have a lot of those problems. And we could really easily test those integration points because there weren't that many of them and they were really well defined. By starting with this comprehensive set of tests, it helped our code stay in that gold standard quadrant just a little bit longer. And it also made our code age better. Okay, we've covered the first two of these. We've talked about encapsulation. We've talked about testing. These are two great ways to make our code age better. The third one I want to talk about is linting. And I want to talk about a specific linter that we used in our HR integrations work. And if you work in a typed language, not Python, Carta is mainly a Python shop, this particular linter won't do you any good, but there are like 8 gazillion linters that you can leverage effectively to make your code age better. Python's an untyped language, right? And we are not exclusively Python, but we're pretty darn close. And as we were standing up this new system, we had to decide if we were going to enforce types in the new code base or not. And because we wanted to have code that aged better, we introduced types from the start. And I personally am like very pro types when it comes to working in an untyped language. Why? Well, because the legacy function in our code looked like this. This is a small oversimplification, but no, it's not much. Like, talk about a function that's really easy to use wrong. You literally don't know what to pass this thing unless you go read the implementation. Like, that's not the most user-friendly thing in the universe. We did not want our get employees call to look like this in our new system. So how does this look when we introduce MyPy, which is it's just a static type checker for Python. There are several others. MyPy is the one that we use at Carta. So in our new system, that function looks much more approximately like this. So now if I pass anything other than a UUID to get employees, my pipeline's gonna break because MyPy is gonna throw an error. And I envy all of you folks who like work in a typed language all the time and need not worry that someone's gonna like shove an integer into your list parameter. Like, it sounds great, but this is not the life that I get to lead. The bonus of adding MyPy, not only do I now know what to pass to this function, I also know what it's gonna return. Like, I now know I'm gonna get back a list of employees. This function is way harder to use wrong than that, which is begging you to use it wrong. Like, you almost would only use it right by mistake. This one is very clear what it's expecting. You know, these are all tools, right? We've talked about encapsulation, we've talked about testing, linting, one specific linter, but like, you know, choose the linters that work best in your code base. The last one I want to talk about, and when I was talking to a friend of mine about this talk, he's like, you're going to talk about code comments? And I was like, I'm going to talk about code comments because I love code comments. I love comments that are like informative and descriptive, and if we're really lucky, sometimes they're funny. Comments make our code age better because they provide us with direction and guidance. They help us understand like what set of decisions got us to where we are right now, or what have the people who have come before us, which bear traps have they stepped in that they have commented on at least lop your foot off in a different bear trap instead of the ones that we already found. This is what I love about comments. And if you're asking yourself like, but isn't good code like self-documenting? I agree with you on some like theoretical scale, but I don't know about you. I have never worked in a code base where this was real. Like, I've just never worked in a code base that I did not feel could really warrant some descriptive and useful comments. I remember early in my career, I heard a more senior engineer say like, well, you know, your good code doesn't need comments. And what I internalized to that was, well, if I add comments, I'm making my code bad. I am 1000% certain that's not what that engineer meant, but it's what I believed for, I won't say how long because it's a little bit embarrassing, but this was a thing that like, I think we have to be careful when we talk about like all good code is self-documenting, because we don't want to instill in people that adding a comment isn't like inherently a bad thing. And comments are really important because code is so much easier to write than it is to read. Like, you're reading some code written by somebody else, or the you of 6 months ago, which might as well be somebody else. Like, it can be really hard to understand why things are the way they are. And a good comment can be a real lifesaver. They describe the why rather than the how. We've probably all encountered the equivalent of this as a code comment, right? Like, yes, thank you. I knew that was a stop sign. This is not what I mean. This is not a helpful code comment. I had to include this one. This is one of my favorite code comments I've ever seen. This is 1000% real. In a real code base that I have worked on in my career at a company whose name will remain hidden to protect the guilty. I don't know. I remember when I read this comment for the first time, I was like, I'm gonna go figure out what that piece of code does. Beats the heck out of me. I have no idea. I guess I do not know if this is a good comment or not, but I guess I appreciate the warning. Like, I don't know. That piece of code was over 7 years old when I encountered it, and I was like, well, I'm not gonna be the one. I do wonder if it's still there. I don't know. When I'm talking about good code comments, I mean a comment like this. So this is obviously not directly verbatim, but inspired by a real comment in our HR integrations. And when we were working on that project, we actually talked about our comments in meetings. I think that we were weird people, but we talked about our comments in meetings as an active extension of the other documentation that existed for this code base. And this is great. Like, it tells me like why this code exists. It tells me that if I'm using it for something else, I'm probably making flagrantly bad decisions. And it links me to a document, and that document helps me understand what trade-offs did we negotiate at the time that we made this decision to get to where we are today. Because there's a high likelihood in some future iteration, we're gonna want to like relitigate those decisions. Make it really easy for that future person to understand what was the decision making that got us where we are. So if we need to reconsider that, we can understand what we should look at as we go forward. These types of comments help our code age better. I have to include this one. Wrong comments are worse than no comments at all. That function does not return true. I don't care what the comment says. Like, nothing is executing our comment to tell us when we just start lying to ourselves. So as we are writing our comments, we need to be thoughtful and remember that they require upkeep and maintenance just like our code does. Okay, I know I'm running up on time, so I want to really quickly recap. Through this lens of this actual real life work we did for Carta's HR integrations migration, we've looked at some ways that we can move our code from those bottom two quadrants closer to the top. We've looked at how we can pay down our tech debt. How can we take code in those leftmost quadrants, move it closer to the right? And how do we build the Paul Rudd of code? This will never not be funny to me. Should I live to be 1,000? But I didn't really tell you, like, how did it go, right? Like, I'm saying we did this HR integrations thing and maybe it blew up 2 weeks after we launched it. Thankfully, no. It's one of our more reliable systems at Carta, even still now, and it's been several years. This code has changed hands several times, moved between different teams, but that resilience has pretty consistently remained. And I think a lot of it has to do with the fact that as we were actively designing the system, we were consistently talking about its inevitable demise. And how did we use the understanding that someday some poor person was going to have to replace this in order to inform the decision-making of designing it up front? This is a project I am really excited to be able to say that I had a part in. And it's been quite a few years now. So I think that I probably have to call this code vintage at this point, but it's pretty darn good, I think. I said at the top that the code we're building today is the legacy code of tomorrow, and that's true. But if we keep in mind that future developer who someday is going to have to deprecate whatever we're building today, we can be the author of the vintage code that's actually like pretty nice to work with, rather than that deadweight code that's unwieldy and confusing. And you never know. The future developer whose day you might be saving, it just might be you. Thanks so much.
Right, anyone have questions? Oh, I got one, all right. I'm gonna try not to walk all around the room. Sorry, where were you?
Hi, thank you for the great talk. I really agree with the point you made about wrong comments being worse than no comments. I was just wondering if you had any suggestions for like tools or processes that could help keep comments accurate and up to date, or yeah, anything.
I have seen a linter in my life that I think was at best directionally correct, but specifically wrong. I do not know of any tooling other than code reviews, which is not a helpful answer. Sorry. I also think about the other tool I think about is like write a comment that's hard to become a lie. Like if you're describing why you're doing what you're doing, unless you change the why, then that's still true. I think it's much harder when you have a comment that describes the how, because you might change the how 7 times, and that's harder to keep that comment up to date. So if you write a comment that's not particularly interested in the specific implementation, it's just going to age better.
All right, any other questions? All right, well, thank you. Oh, one here.
Hi. It's funny that you're talking about like funny comments, just to start off, kind of like, so we have this system for onboarding, right? And literally as the comments pop up, like on the service start, it's a picture of a boar. So,
That's amazing.
Yeah, it was my skip level boss who wrote that one. No, but I wanted to see what you feel about to-do comments, right? Because they pop up a lot. And if you check legacy code, obviously it's riddled with to-do codes, 7-year, 8-year to-do codes. How do you feel it's the best approach to those to-do comments, right? Like, is it worth revisiting? Is it worth removing? Is it worth, because they do have some history attached to them. Yeah, just wanted to see your thoughts about that.
Is this when I go back to the SpongeBob "it depends" meme? So I think to a certain degree, it does depend. It depends on like the culture of your organization and like how much are you lying to yourself. Every to-do comment is a little bit of a lie. It's just like a spectrum of how much of a lie it is. And I think that ideally, what we leave for ourselves is an artifact to help us understand why we got here and what potential future might look like, more than a specific to-do comment. I have seen some organizations that are quite studious about their to-do comments and have like linters that figure out how old they are and like send you a nasty Slack message to you and your boss, and then eventually like to the CEO that's like, well, Shawna said 2 weeks ago that she was going to do this and she didn't, and she's in trouble now. Does that work everywhere? Maybe, almost certainly not. Does it work some places? Probably yes. I think the important part when we're thinking about like what artifact are we leaving in our code to help future us is that whatever your organization is going to find the most useful is the right thing. And the day that your to-do comment can like go to kindergarten, let's just delete it and move on with our lives. Like, I think we're lying to ourselves at that point. Like,